Here are some rules about functions. In order for it to be a function, it has to follow these rules. These are like specific things. This is what mathematicians have decided defines a function. It has to work for every possible input value. Now, that doesn't mean that it has to work for every single number. It just means that everything that you're saying, like it will work for this, it has to work. The other thing is that each input only can have only one output. You can't put in an apple and then get out apple slices and orange slices. You have to be able to put in an apple and always get out apple slices. Or you have to put in X and always get out a very specific number of Y. Some more rules. Functions relate each element of one set to another set. Now we're using some fancy terminology here. A set is a collection of numbers. It's like I collected the set. An element is a specific part or a member of said set. So if we have a bunch of numbers, an element is just one of those numbers. Here are some examples. We have the set 0, and by the way, we use curly brackets to help us find out, like to find them. We have the set 0, 1, 2, 3, 4, 5. This is a set, it's a collection of numbers, and an element is one specific number. So 0 is an element of this set. 3 is an element of this entire set. And you have this other set over here. There's another type of set here, and you notice that it has these 3 dots. It means that it's like an infinite set. We have shoes and socks and jeans and shirts and caps and watches. These are all things that we can wear. It's like a collection of things that we wear. It's our set. And with this infinite thing, it's saying that you can keep going. You can keep on adding things. We're not defining everything. Now, there is a limited amount of things that you can wear, but it kind of gets the point across. And here, let's think about different ways of thinking of functions. You have these inputs, and they're all mapped to an output. Now, it doesn't matter the fact that they're crisscrossed and whatever. You have one input goes to one output. An input can go to the same output, but the most important thing is that each input has an output, and none of these inputs are being like doubled. You don't see the 2 going to 0 and 3. It's going to only 2. Another example, here is this beautiful graph. We have x's along the x-axis, this horizontal, and we have y's, our outputs, along the vertical. Our x's, you can plug in any number along here and you will get out a y. You'll get out only one y. So if I were to plug in 0, I'm getting out 0. If I were to plug in -5, I'm getting out 6. And all of these things have a specific input and a specific output. Now there's a couple of tests that we can use to determine if a function or if a thing really is a function. And there's a few ways. First, we can map it. So remember that every input should only have one output. If for some reason you have an input and it spits out multiple outputs, then it's not a function. If an input is missing an output, it's also not a function. Every input has to be defined as an output, has a defined output. If an output is missing an input, in other words, you have too many things in your outputs, that doesn't matter. You have an input that all goes to the same output, that also doesn't matter. It doesn't change anything at all. So we have some function tests. Another set of them, which is our vertical line test, and that's basically you draw a straight line through a graph. If it crosses the graph more than once, that straight line, anywhere, any straight line that you draw, if it straight vertical line down the graph, if it crosses more than once, it is not a function. Why? Because that means that this input, that specific x value, has multiple outputs, and we can't have that happen. So let's test some of these functions. We're going to do a vertical line test on these ones. And here, I'm going to try my best to do a vertical line. Here, you notice it only crosses once. If we do another line, it's still only crossing once. And here, another line crossing once. That was a terrible vertical line, but here, another line crossing once. Each individual vertical line can only cross the graph once. You can have as many vertical lines as you need, but they should only cross the graph once. Here's an example of something that's not a function. So this one is a function. This here, let's draw as nice of a straight vertical line as we can. It crosses 1, 2, 3, 4, 5. That means for that specific value of x, we're getting out 5 different things, which is not allowed. Here, same thing, 1, 2, 3, 4, 5. Oh, maybe if we do it here, we'll get 1, 2, 3, 4, 5, 6. It's not a function because you're putting in something for x and you're getting out one of 6 different y's. And that doesn't really help us predict the future. It doesn't really help us with math. It's not something usable as a function. It is usable event like for other things, but for math and functions it isn't. Now, for example, if we had this weird thing that's all like loop de loop 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 loop, and we were to turn it on its side, that would be a function. But because of the way that it's set up, it's not a function. Here's another set of things. We're going to test these. We have 2 goes to 0, that's good. 3 goes to 3, that's fine. 3 goes to 4, and that's where it breaks because now we have 3 going to 3 and a 4. It has 2 outputs for 1 input, so that's a no. Here we have 0 to 5, okay. 1 to 6, fine. 2 to 7, okay, whatever. 1 to 8, wait a second, we have 1 to 6 and then 1 to 8. That's where it breaks. We have 0 and 0, 5 and 9. That's also breaking. Here, let's see what's wrong with this one. If it is, it might be okay. 8 goes to 0, fine. 4 goes to 5, fine. 7 goes to 7, fine. Or 5, fine. 8 goes to 3, that's fine. There is an extra output here, but it doesn't matter because of the fact that every input has something attached to it. So it's as long as every input has something attached and every input has only one answer, it doesn't matter. Who cares? So we're going to do this quick check, and I'm sorry I got really bad. This A belongs here. But we're going to determine the relationship if each relationship is a function. So I want you to pause, take a moment to do that really quickly, and then after you're done that, you are done with the lesson for today.